Hello friends, in my previous lecture we have studied some important petrophysical properties like porosity and permeability. So in this lecture we are going to study fluid saturation and other important surface properties. So next property is fluid saturation. It is defined as the fraction of the pore space occupied by the particular fluid. In multiphase reservoir system, saturation of the each fluid like oil, gas and water is given by following equations. For oil saturation, saturation is given by volume of oil divided by volume of pores, that is VO upon Vp. Similarly, for gas saturation, it is given by volume of gas occupied in pore divided by total pore volume, that is Vg upon Vp. Similarly, for water saturation, it is given by Hw is equal to Vw divided by Vp. Vw is the water saturated in pores divided by total pore volume. So the total pore volume is the sum of volume of water in pores, volume of oil in pores and volume of gas in pores, and the total saturation is 100%. So Hw plus So plus Hg is equal to 1. So total sum of this all fractions will be 1 and it is 100% saturation. So in the diagram, in the pores in different regions are occupied by the gas, oil and water. Now next is the interfacial tension. A measure of intermolecular or intergranular force responsible for a specific fluid saturation is interfacial tension. So in petroleum system, for oil and gas system it is 0 to 15 dyne per centimeter. In water oil system it is 15 to 35 dyne per centimeter. For water gas system it is 35 to 55 dyne per centimeter. For air mercury system it is 48 dyne per centimeter. For air water system it is approximately 72 dyne per centimeter. Now determination of fluid saturation. So there are two most important method. One is direct and other is indirect method. So in direct method, generally core sample are analyzed, core sample are extracted from the reservoir and they are analyzed by various laboratory methods like retort method, second is the vacuum distillation method and third is the distillation extraction method. Next is the indirect method. In indirect method, the capillary mechanism, through capillary mechanism we will determine the fluid saturation. Means first the capillary activity in reservoir rock is analyzed and from that saturation is gained. Next, typical cross section of saturation in reservoir, and third is the scanner survey. Other important methods are interproperty correlations like porosity, permeability and capillary pressure saturation relation, and next is the statistical models. Various statistical models fluid saturation is determined. So fluid saturation is defined as the total volume of the fluid divided by pore volume. So volume, saturated volume of oil is given as volume of oil divided by pore volume, Hg volume of gas divided by pore volume, water saturation Hw volume of water divided by pore volume. So saturation of each individual phase ranges between 0 to 100 and the sum of all these fractions will be 100. So Hg, So, Sw is equal to 1. And next is critical oil saturation. At this particular saturation, the oil remains in the pores and will not flow. So this saturation is called critical saturation. Below this saturation, oil will be immovable and it will not flow. Next is residual oil saturation. After the production, the remaining oil left behind in the displacement process, it is characterized by saturation value that is larger than the critical oil saturation, and it is called residual oil saturation. Next is movable oil saturation, SOM. The pore volume occupied by movable oil, if SWC is connate water saturation, SOC is the critical water saturation, then SOM is equal to 1, that is 100% saturation, minus SWC connate water saturation minus SOC, that is critical oil saturation. Finally, critical gas saturation, SGC, it is the gas saturation above which gas begins to move. So below this saturation, gas will be immovable. Next is critical water saturation, SWC. It is the maximum water saturation in which the water phase will remain immobile. So average saturation of oil, gas and water can be obtained using these formulas. So oil saturation, it is summation of I equal to 1 to n, that is phi I Hi SOI divided by summation of I to I is equal to 1 to n phi I into Hi, where phi I is the porosity of different samples, H is the thickness various samples, and SOI is the saturation various samples. So using this formula we can get the saturation of oil, gas and water. So for example, the 6 samples are given, and it's for all these 6 samples thickness, porosity and saturation data are given. So using this formula we can calculate the average saturation of oil, water and gas. Next important property is wettability. Wettability is basically the other characteristics of the rock. It is the tendency of one fluid to spread one or other to a solid surface in presence of other immiscible fluids. Means if a fluid, how easily it can coat the rock surface, it is called wettability. Significance of contact angle. As the contact angle decreases, the wetting characteristics of the liquid increases. The complete wettability would be evidenced by a zero contact angle, and complete non-wetting would be evident by a contact angle of 180 degree. And the contact angle between 60 to 90 degree will tend to repel the liquid. So depending upon the contact angle we can define the fluid. If it is in the range of 0 to 90 degree, then it is called non-wetting phase. If it is 90 degree, then we call it even surface, and if it is beyond 90 to 180 degree, then we can call it the ring phase saturation. Water weight reservoir rock. For water weight reservoir rock is water weight if water presently weights the rock surface, means it prefers the water to weight. The rock is water weight under the following condition: sigma Ws. Sigma Ws is basically surface tension between water and solid surface. So sigma Ws is greater than or equal to sigma Os. Sigma Os is the surface tension between oil and solid surface. So in that case, adjacent tension AT will be less than 0, and the contact angle theta will between 0 to 90 degree. If theta is close to 0 degree, then it is considered to be strongly water weight. Next is oil weight reservoir rock. So the reservoir rock is oil weight if oil preferentially weights the rock surface. The rock is oil weight under the following condition: sigma Os, that is surface tension between oil and solid surface, is greater than sigma Ws, that is surface tension between water and solid surface. In this case, AT is greater than 0 and adjacent tension will be positive, and theta, the contact angle, will be in the range of 90 to 180 degree. So if theta is close to 180 degree, the rock is considered to be strongly oil weight. Next surface property is capillary pressure. So the capillary forces in petroleum reservoirs are the result of the combined effect of the surface and interfacial tension of the rock and fluids, the pore size and geometry, and the wetting characteristics of the system. When two immiscible fluids are in contact, a discontinuity in pressure exists between the two fluids, which depends upon the curvature of the interface separating the fluids. This pressure difference is called capillary pressure and is termed by Pc. So there is one important relation between capillary pressure and saturation, as well as the capillary pressure is related to the surface tension. So this is the relation for oil filled system. There may be gas liquid system or oil water system. So for gas liquid system, the relation between capillary pressure and surface tension is given by this equation. So Pc here is the capillary pressure, 2 sigma Gw cos theta divided by R. Here sigma Gw is the surface tension between gas water interface, and cos theta is the contact angle, R is the capillary radius.